Right, good afternoon, everyone. Happy to see you all again. This is another new week again, okay? Very cool coming again. Okay, you all remember last week what you all learned or not? Okay, last week we started with a new chapter, chapter 4, isn't it? Chapter 4. Okay, what is the title of the chapter? Anyone can tell me? Do you remember or not? What is the title of the new chapter? Jin Yi Hong, what is the title of the new chapter? Jin Yi Hong? Jin Yi Hong. Justin, what is the title of the new chapter?
Heat.
Heat. Justin, he can answer everything one, okay? Heat, one word only, heat, right? So our new chapter, chapter 4 is heat, okay? And you must remember a little bit, at least you must remember a bit what you have learned in your last lesson now. Heat. Okay, I would like to ask a few questions now. Don't worry so much. You just try to answer. You cannot answer, you just say you don't know. Don't need to shy. Okay, the first question. What is the meaning? What is the meaning of thermal equilibrium? Thermal equilibrium is what? What is thermal equilibrium? Hashini, can you answer? What is the meaning of thermal equilibrium?
Same temperature.
Yes.
Same temperature. Net heat transfer becomes zero.
The second answer is what?
Net heat transfer becomes zero.
Yes, very good. Okay. It's a condition now. Two objects, they are in contact, right? So they achieve same temperature. One is same temperature. Another one is the rate of heat transfer becomes zero. Net of heat transfer is zero. If these two situations is achieved, that means the two objects is in the state of thermal equilibrium. Okay. And another question, second question. Last lesson also you learn a few types of thermometer, right? Thermometer. Okay. What are the types or names of thermometer you have learned? Yong Jiawei. Yong, can you answer, Yong?
Mercury thermometer.
Mercury thermometer. Second one?
Resistant thermometer.
Resistant thermometer. Third?
Thermocouple thermometer.
Thermocouple thermometer. Very good. And one more last?
Gas thermometer.
Gas thermometer. Yes, very good. Yong Jiawei. Okay. That was types of thermometer. Okay. And after that, now from types of thermometer we have learned, right? Then we learned something very important before we stop last lesson. Okay, that was calibrations of thermometer, right? What is calibration now? Kevin Lim, calibration of thermometer. What is the meaning of calibration? Calibration means what? What is calibration of thermometer now? What is that now?
Don't know, sir.
Don't know. Okay, never mind.
The process of making upscale.
Yes, correct. Very good answer. Then how come you say you don't know? It's a process of marking up the thermometer, marking up the scale. You have to put the scale, mark the scale. So the process of marking the scale of thermometer, right? We call it calibration of thermometer. Okay. And next question. There are 2 points we have to take one, very important in calibration of thermometer. When you calibrate the thermometer, right? There are 2 important points we take now. What are the 2 important points? What are the 2 important points we take during the process of calibration of thermometer? Carmen, okay, Carmen, can you answer? What are the 2 points we take?
Lower fixed point and upper fixed point.
lower fixed point is 1. The other one is upper fixed point, correct not? Okay. I think most of you can answer lah, huh? Okay, so we carry on now, huh? Okay, we solved somewhere here, right? Last week, okay? We look at this one now, okay? You see now, calibration. So I take out the pen first, huh? Let's see. 2 people coming in. Who are the 2? Huh? You know what I clicked just now? I think I clicked remove from there. I hope they come in again now. Sometimes I click too fast. I don't know what I clicked. Yeah. Okay, in the process of calibrations of thermometer, first you put the thermometer inside the ice, cold, right? So you put inside the ice, it will go up. The mercury only go up a little bit. So when mercury stop here, so you mark this one 0 lah. So this is lower fixed point. Then after that, this thermometer put in the steam, hot steam you put here. So of course the thermometer mercury will go up until here, then it stop here. So this is definitely 100 degrees. So now you have 2 marks already. One is 100 upper fixed point. The other one is lower fixed point. You have 2 points enough already. So the rest, you just mark it evenly, divide it evenly to 100 division. That's all. Okay, that finished already the calibration of thermometer, right? That means now, every single this thermometer produced in the factory must go through calibration individually, one and all. Cannot say one batch of thermometer they do the same one. No, they have to do one by one. Calibration have to be carried out one by one. Okay. All right. Now there is another thing I want you need to learn tonight. You look at this diagram here. See here now. Okay. When you put the thermometer inside the ice, right? Mercury go up here. This length is called LO. LO means length of the mercury when temperature 0. When temperature 0, right? What is the length of the mercury? So it's LO. Okay. Another one is when you put inside the thermometer, put inside the steam, right? The mercury will go up very high, right? Go up very high. And this L100 is the length of mercury when the temperature is 100. It's very important, you know. You must know L0, you must know L100 because we're going to use a formula to calculate. Okay, we look at one example here. Okay, one example here. Okay, look at this example. When this thermometer put in temperature X0, right? So the mercury length is here. So you label this one L0. Okay, L0 now. Length of mercury when temperature 0. Okay. Then when you put inside the steam, temperature is 100, right? Then the length of mercury is L100. So remember, you know, L0 is length of mercury when temperature 0. L100 is a length of mercury when the temperature is 100. Okay. Now, same thermometer put inside another liquid. This temperature we don't know. We don't know the temperature one. We are going to find this temperature. Then the length of the mercury is L theta. So you have 3L here, remember. Later on, you're going to use this formula, you know. L0, length of mercury when temperature 0. L100, length of mercury when temperature 100. Another one is L theta. L theta, theta means an unknown temperature. You don't know the temperature. Then the length is L theta. Okay? Now, in this question, when you want to find what is the temperature of this theta, right? And you use this formula, theta equal to L theta, this length, L theta minus L0 divided by L100 minus L0 times 100 degrees Celsius. This one is very important. I don't encourage you to use this formula. Follow this one. Okay. You want to find the temperature theta, so you take L theta minus L0 divided by L100 minus L0. Here must be L0, L01 times 100 degrees Celsius. Okay. By using this formula, you can find what is the temperature here if given the length. Understand? Okay, copy down this formula. Okay, copy down the formula. Okay, now. Yeah. Now look at one example here. This few things you learn first. Theta is the temperature of substance, 0 ice point, 100 steam point. This one is L0, length of mercury when in the ice point. L100, length of mercury when in the steam point. X is the length of mercury when thermometer placed where you want to find the temperature. Okay, now you read this question. Come on, read this question and then we see how to answer it. Read the question. The length of mercury column in the thermometer at the ice point, 0 degree, and the steam point, 100 degree, are 12 cm and 20 cm respectively. That's right. That's why you see now you put L0 is 12, okay, 12 cm and temperature 0 mark. And when temperature 100 is 20 cm, so L100 is 20 cm. Now, when a thermometer is placed in the liquid, the length is 15 cm. Then what is the temperature of the liquid? And now, the question is like this lah. L0 12 cm, L100 is 20 cm, L theta 15 cm. So this theta is how many degree? You're going to find the temperature, you know. Okay, you do like this, use this formula. Now you see the solution. Theta equal to L theta minus L0 over this. Okay, you put in now. L theta is 15, this is 15 cm. L0 is 12 cm. L20, L100 is 20 cm. L0, of course, is 12 times 100. So this, you substitute, you calculate, you get the answer. Understand? So you know how to use the formula. Okay, please copy down the example, copy down the answer. Okay, copy the answer now, please. Okay. Okay, after this, can you try the next question? Use the same formula to answer the next question. The next question. Okay. The answer is already here. You can check yourself. The length of mercury thread in the thermometer 4 cm, 24 cm in 0 and 100. So this is L0. L100 is 24. What is the length of the thread when the temperature is 65? You are given the temperature, you are asked to find the length. So same formula. Temperature theta 65, you are asked to find the L theta. L0 is 4 cm, L100 is 24. So this one same mark times 100. So here you got 20, right? 20 cross over here, 20 times 65, so you get 1003, right? 20 times 65, so you get 1003. This 100 bring over the divide, so become like that. Okay. So here, that plus 4. I think the answer is 17. Can you please check? 17 now. 13 plus 4, so the answer is 17. Okay. Yeah, understand? So you know how to use the formula already, right? So remember, this formula is very important. Okay. Calculation part you must know. Okay. All right, next. Next is you look at here. Let's learn a little bit of theory. This one is mercury thermometer. Okay, the parts remember, the parts. This one is thin wall glass bulb. The name of this part is bulb, okay, bulb. And then the glass wall must be very thin one, you know, cannot be very thick. Okay, let me tell you here must be why must be very thin. The bulb here must make from the glass, very thin one, thin wall glass bulb. Okay, why need to be very thin? Because thin glass, so the heat can go in very fast. The heat energy can go in very fast when the glass is very thin. Understand? So when the heat can go in very fast, right? It make the mercury expand very fast. So meaning that this thermometer will become very sensitive. Sensitive is good, understand? I'll repeat again. Bulb here, the glass must be very thin. Thin, the glass must be thin, so that the heat can easily enter into the thermometer and make the mercury expand very fast. This will improve the sensitivity of the thermometer. The thermometer become very sensitive. Sensitive means very good, very accurate. Understand? And this is mercury, you know, capillary tube are here. This capillary tube must be narrow. Must be narrow. Narrow, cannot be so big one, must be narrow, you know. Narrow means the mercury can expand faster. It can go up faster, isn't it? When the tube is narrow, so it can expand faster. This also same make the thermometer more sensitive. It can go up faster, right? It can respond faster. Okay. Now look at here. The specific thermometric of used in the thermometer is a change of volume of mercury with the temperature. This one you know, last week learned already. The volume of mercury increases, okay? Okay, now highlight this one. The sensitivity of thermometer can be increased. Sensitivity means we want to make the thermometer respond faster, more sensitive. The thermometer more sensitive is better. So what we need to use is thin wall glass bulb. The glass bulb must be thin, then sensitive. I told you just now. Another one is reducing the diameter of capillary tube. This capillary tube must be narrow. Understand? Narrow, so the mercury go up faster. So sensitive. Okay. Right. Next part is mercury is used. Why we choose mercury? Why don't choose water? Don't use oil. Why choose mercury? There are 4 reasons we choose mercury. Also, essay question you must know. Why mercury is chosen? Because it has a higher boiling point. The boiling point is higher. So meaning that when the mercury boiling point is higher means you can use to measure higher temperature. Okay, higher temperature. Then only it start to boil, isn't it? So meaning that mercury thermometer can be used to measure higher temperature. Okay, the second reason is does not stick to the glass. Okay, thermometer will not stick to the glass, so it go up, then it can come down. It never stick on the glass, isn't it? So that is good. Understand? Does not stick to the glass. Once it go up already, it can come down, so you can still see very clean. Okay, nothing stick on the wall. Okay, next is opaque. Opaque means not transparent. Not transparent means the light cannot go through. The light cannot go through one. Opaque. So it's opaque, therefore easier to read. Okay, opaque means when you take out, you want to read, right? It's not transparent, then easy to read. Easy to read. Opaque. Mercury is opaque, not transparent, so easy to read. Okay. And last, this is the most important. Mercury can expand and contract uniformly. This is the best. Okay. Mercury now, it can expand or contract uniformly, follow the temperature. So this makes mercury the best liquid used so far. Okay. Because mercury expand and contract uniformly with the change in the temperature. Understand? Okay, right? So far okay or not? So far are these two waiting outside or I don't know, they are waiting me. Let them come in first. Jiu Ling and Jiu Ling, how are you? Julian, I didn't see your name just now, no? Zhao Yi, Zhao Yi. So when I'm teaching already, you come in, I cannot see you at some time, so I cannot allow you to come in. Okay. So now I think most of you here, right? Except those who cannot make it tonight one, okay? Okay, so far I can understand or not? Chai Pei Xin, can understand? Where are you, Chai Pei Xin? I must check you all, no? Some of you have disappeared one day, I must call your name. Chai Pei Xin, where are you? Huh? Just type you need one to. Chai Pei Xin say can, so I can understand us, you can follow, okay? Menti Te, where are you? Menti? Menti, I can follow the class or not? Can follow the lesson? Menti Te also want to type with me, don't want to talk. Can, okay, she said can, okay, good. Okay. Nicole Chuang, how about you? Can follow or not? Nicole?
Can.
Can follow. Caleb? Caleb, are you there, Caleb?
Yes, sir.
Can follow or not? Caleb?
Can.
Cheris? Cheris can follow or not?
Yes, sir.
Cheris?
Yes.
Yes, very soft, I cannot hear. Okay, Chua, Michelle. Okay, so far Michelle Chua can follow.
Yes, sir.
Can follow. Liao Ping Hao can follow.
Yes, sir.
Justin, no problem. Justin can follow.
Can.
Okay, come, we move on now. Okay, the next we have to answer all the questions, including the essay question, Okay, I know you don't like to answer one. Okay, look at the objective, like we go through very fast. Okay, I pick out something, this one you don't see first here now. Which of the following is true? So heat is the form of energy, so answer B. Heat is the form of energy, temperature is a degree of hotness, isn't it? Right? Heat is and temperature both answer are correct. Scalar quantity, they are scalar quantity, both are scalar quantity. Okay. Heat, temperature also scalar quantity. Scalar quantity means they don't have direction one. Okay. And also both measured in SI unit. So both answer also correct lah. So circle 2. Both also measured in SI unit. Heat in joule, temperature in Kelvin, right? SI unit. All right. Question 3. 0 degree change to Kelvin. Degree change to Kelvin, so you add 273. Correct or not? You add the number 273. Okay, later on in lesson 4, only you know why it's 273 lah. Now you just take the number first, okay? You want to change Celsius to Kelvin, so you add 273. So it's 273 Kelvin lah. So meaning that 273 Kelvin same as 0 degree Celsius, Okay. Okay, question number 4. Thermal equilibrium, meaning that when thermal equilibrium is reached, so the temperature must be the same. Just now Hashini already said, temperature PQ must be the same. Okay, next question number 5. Okay, read the question. Diagram show 2 copper block. Okay, this one hotter, this one 50 degree, this one 30 degree. Okay. The initial temperature is 50-30. Okay, which statement is correct when they are thermal equilibrium? Okay, thermal equilibrium means finally both of them become same temperature, but I think here don't have the answer same temperature, right? Okay, if no same temperature, you have to look for another answer, So the answer is D. Net rate heat flow between LM0. What is the meaning of net heat flow becomes 0? What is the meaning of that? Okay, net heat flow becomes 0 means when these two are in thermal contact, so heat will transfer from hot object to cold object, this are no unusual happen one. Most of the happen is the heat energy moving from hot object to the cool object, right? But we cannot deny, you know, there's a little bit of heat also moving from cold object to the hot object also can happen one, you know. But only thing is this sun heat flow here is more. That's why the arrow is bigger. Sid Eiling now come. Sid Eiling, I think she's supposed to be the first one, and I disappeared now come again. Okay, this arrow big means more heat flow from here to here lah. But also at the same time got a little bit heat flow from here to here. Okay, this will happen until finally both heat flow become the same. Here to here become the same. When become the same, when you minus, right? When you minus, you find the net heat you minus, right? So you get 0. Net heat flow 0 means heat move from L to M to L become the same. So when you minus a heat flow, so it becomes 0 lah, because they are the same. Left to right, right to left becomes the same. Understand? So that is the meaning of net heat flow becomes 0. So when net heat flow becomes 0, automatically they are same temperature one. Yeah, okay. Okay, number 6. Which principle used in mercury thermometer? Okay, the principle of thermal equilibrium. So this word very important. Thermal equilibrium. This is a thermal equilibrium principle used in all the thermometer. Okay, if question asks what is the principle used in a thermometer? So your answer is thermal equilibrium. Okay, thermal equilibrium means something like this. When two things touching each other, heat transfer happen. So heat transfer until a stage where both of them become same temperature, right? And the net heat flow becomes 0. This is called the principle of thermal equilibrium. Okay, right. Number 7. The physical quantity which varies with the temperature. Okay, the thing varies means changing with the temperature is called specific thermometric property lah. Specific thermometric property. Example is the mercury. The mercury will expand and become hot, correct not? So that one is the volume of mercury increases when the temperature go up. So meaning that here the physical quantity that varies with the temperature for this mercury thermometer is specific thermometric property lah. In other words means thermometric property for mercury thermometer is the volume of mercury expand with the change in the temperature. Understand? Okay, the next. Now here, they ask you one by one. Ask you which one is correct, which one is wrong. Okay. Which one is true? Okay, only one is correct. Mercury thermometer. The thermometric property is mercury volume varies with the temperature. This I explained to you already, right? Okay, this one is correct now. The rest all wrong, you know. Thermocouple supposed to be electromotive force or the wattage, varies with the temperature. Right now, it's not potential different. It's electromotive force. Yeah, different one, no? Electromotive force. In Form 5, you learn now what is the difference between potential difference and electromotive force. Okay, electromotive force vary with the temperature. Then for gas thermometer, it's not gas density, it's a pressure of the gas. Pressure of the gas varies with the temperature. And the last, resistant thermometer. Okay, resistant thermometer, the thermometric property is the resistance varies with the temperature. The resistance change with the temperature. Okay, Okay, number 9. Regarding the fixed point, okay, which one is lower fixed point? At the beginning of the lesson, someone already answered, right? What is upper fixed point? Okay, lower fixed point is which one? Upper fixed point is which one? Okay, let's hear from Liao Ping Hao. Can you tell me which answer lah? You have the paper with you or not, Liao? Question number 9. Can you tell me what answer?
Answer is C.
C. Lower fixed point, upper fixed point. Let's see. Yes, correct. The answer is C. Okay. Lower fixed point is the freezing points of water or the ice, right? And the upper fixed point is a boiling point of water, which is a steam point. Okay, answer C, correct. Liao, your answer is correct. Okay, number 10, calculation. You see, use this formula. Yeah. Length of mercury, ice point, steam point, 5 cm, 20 cm. Okay. So L0, 5. L100 is 25. When a thermometer places a liquid, the length now is 12 cm. Now L theta is 12. So find temperature. Okay, use this formula. L theta 12 cm, 0, 5 cm, 100, 25 cm. This one fine, time 100 degrees Celsius. Calculate, you get 35. So the answer 35. Okay, this calculation very simple. Can you remember the formula? Okay, question 11, use the same formula. Length of mercury, X cm, 20 cm respectively, 0 degrees, 100 degrees, 20. What is the length of the thread of the thermometer placed in the negative 25 degree? You see, using formula now temperature given already negative 25. Okay, so here given this L theta not given, you ask to find the length of the mercury during this temperature. When 0 degree X cm, 100 degree 20, 0 degree times 100. Okay, so it's 12 here. 20 minus 6 is 12. Crossover 12 times this, you get negative 300. And the 100 bring over to divide. Okay, you divide here, you get negative 3. Negative 3 plus 8. This one bring over become plus 8, so you get 5 cm. Okay, so meaning that during this temperature, negative 25, right? So the length of the mercury is 5 cm. Okay, so can understand, Okay, question number 12. Read the question. Thermometer which is not calibrated, mark 200 small division, already marked there 200 skew, Okay, between the ice point and the steam point. We know that between the 0 degree ice point and the 100 degree steam point already got 200 marks. They marked already. They already marked there. Okay, so now when the thermometer inserted into a liquid, the level of mercury is at the 120 mark. So you can assume this is L theta. Okay. Then you see, I see the formula. L100 is 200. L0 we put 0 lah. Meaning that between 100 degree and 0 degree, there are 200 division now. So this is 200, this is 0. Now this is 120 minus this one 0 and 100. Solve here, you get 60 degree. Okay. 60 degrees Celsius change to Kelvin. Okay. Add 273. So you get 333 Kelvin now. So the answer. Yeah. Even though this question never say ice point, what is the length, steam point, what is the length, never mind. But if given 200 small division, you can assume that L100 minus L0 is 200 minus 0. Okay, this is L theta. Okay, understand? Okay, question 13. Okay, why the answer is A? Why? Which liquid ABCD can be used to make a liquid in glass thermometer to measure this temperature? To measure this temperature, to measure negative 50 to 50. Why we choose this liquid? Why? Okay, you see now, we must choose the mercury the liquid the freezing point must be lower than the lowest temperature. The lowest temperature you want to measure is -50, right? So you have to choose a temperature, the freezing point must be lower than this. And the boiling point must be higher than this higher temperature, right? So you want to measure the lowest -50, the highest 50, right? So you must choose a freezing point lower than this, which is 115 negative. And the boiling point must be higher than 50. Okay, so the answer A lah. Yeah. All right, next. Next is what already? Okay. Which modification will increase the sensitivity, okay, to make this thermometer more sensitive? More sensitive means it can respond faster, can measure smaller temperature. That is called more sensitive. So we already learned just now, right? So the answer is, okay, using a narrower capillary tube. The capillary tube must be narrow lah, okay? The rest all wrong one. The rest all wrong. Okay. Okay, number 15. Mercury is used because this is the best answer. Mercury expand, contract uniformly with the temperature change. Okay. Yeah. And number 16. Structure question just label lah. P is capillary tube. Q is bulk. Okay. This part is bulk. Okay. Bulk. What principle use? The principle of thermal equilibrium, okay? Remember, principle of thermal equilibrium, okay? State the thermometric property, okay? The answer is, volume of mercury varies with the change in temperature. Means the volume of mercury will change when the temperature changes, okay? That one is thermometric property of this thermometer lah. Okay. And the next one is a calculation. You should see the answer can already. Okay. Can you see yourself? Length of mercury, 12 cm is 0 degree. 20 cm, 100 degree. Okay. So what is the length when it's 20 degree? Okay, use the formula lah. 20 degree. L theta to know. L0 is 12. L100. Okay. All right, here 8 times 20, 160. This 100 bring over the dy. So 16 plus 12. I think the answer not correct, no. Oh, sorry. Correct. Here is 1.6 only. 1.6 plus 12, so it's 13.6. Okay, correct. Okay. And the last part. Temperature when a thermometer placed in the substance cause the length to become 7 cm. Okay, L theta 7, no? L0 is 12. L100 is 20. L0 is 12 times 100 degrees, so you get the temperature is negative. Okay, negative 62.5. Okay, I think so far okay lah, this part. Okay, far okay or not? You all got follow or not? Got follow or jot down the answer one or not? Jing Han, do you follow the lesson and then you jot down, you copy down the answer? Did you follow or not? Jing Han, no sound already, Jing Han. What type? They want to chat with me. So he said yes. Okay, yes, sir. Okay, thank you, Jing Han. And let me see another one. Lim Ching Wen, you copy the answer, copy the notes or not? Lim Ching Wen, Lim Ching Wen, do you copy
Yes.
Yes, Gong Fan Sin, you follow or not? Gong Fan Sin?
Yes, teacher.
Okay, thank you. Tan Cho Ming. Tan Cho Ming, you follow or not? You copy or not? Tan Cho Ming? He don't want to talk because he said that internet very slow. Okay, yes, he answer here. Yes, thank you, Tan Chua Ming. And Kian Leong. Kian Leong, are you there?
Yes. Yeah.
You got print out the notes or not? Huh?
Got.
Okay, good. Okay, thank you.
Okay.
Sim Pun Keng. No, this boy, no one always sit behind one. Sim, are you there? Sim Pun Keng. Sim. Sim no sound already. Disappeared. Tai Ka Lok. How are you, Tai Ka Lok? Tai Ka Lok. You follow the lesson or not, Tai Ka Lok?
Yes, sir.
Got or not?
Yes.
Got. Very soft now, your voice, okay? Chiu Ling, can follow or not? Chiu Ling, you came in late, can follow or not just now?
Yes, sir.
Chiu Ling? Can follow or not? Half an hour late, you came in, can follow? No answer, okay? Let's meet Chong. Chiu Ling answer already. She said yes. Okay, thank you, Chiu Ling. Okay. Lakshmi, are you there? Lakshmi Chong.
Yes, sir. Yes, sir.
Follow the lesson or not? Lakshmi.
Got, sir.
Got. Okay, thank you. Keng Sing Yu. Keng, you follow or not? Keng?
Yes, teacher.
You got follow, All right. Okay, come, we carry on, Okay. Okay, the next one is the more difficult question already, okay? Now you read the question. This one is an essay question, okay? There's a lot of answer. When these are SPM question, you all must have a full step paper to write out the answer already, okay? The whole question, 20 marks, essay question, okay? So from 4 students, you are still follow this format, your SPM, okay? The only difference is you don't have paper 3 anymore. Paper 3, the experiment you write in paper, written experiment no more. Okay, but they replace it with the practical test, even worse. Practical test means you need to really carry out the experiment in the lab, then write a report. Okay. Yeah. Question number 17. You are representing the country and carry out a research project in the weather at the North Pole, very cold. The temperature you are supposed to measure is between -40 to negative, or negative answer, or negative temperature, very, very cold. Okay. One item of the equipment is thermometer. You must bring along a thermometer. Okay. But this thermometer must be something very special one, because you can see the temperature you need to measure is all sub-zero one, below 0 degree, or negative one. So definitely cannot use a mercury thermometer. Later on, you see why. Mercury thermometer not suitable to use negative temperature one, okay? And now you see, state the principle used in liquid glass thermometer, okay? First question, 1 mark. So, okay, I ask someone to answer now. Justin, can you answer? What is a principle used in liquid glass thermometer, Justin? Justin, are you still there?
Yes.
What is the answer?
Thinner
What is
wall
the
glass bulb.
principle used?
Thinner wall glass bulb. The wall glass of the bulb must be thin.
No, this question. The principle used in liquid glass thermometer. What principle used? Justin?
Thin.
What principle use, right? Liquid glass thermometer. Okay. Right. The answer here now is the principle of thermal equilibrium. Understand? Thermal equilibrium. Okay. The answer here, you see.
Okay.
The principle of thermal equilibrium. I don't know what answer you say just now, Justin. I cannot hear, you know. Thermal equilibrium is a principle. Okay. Question B. 4 marks question in the SPM. State how a liquid glass thermometer can be used to measure the body temperature of a sick person or a patient, you know. So you need to explain how you use a thermometer to measure the temperature. Of course, in your answer, you have to put the physics concept. You cannot say, put the thermometer inside the mouth, then get the wait for the temperature to go up. No, like that cannot. You are not using your physics concept, you know, cannot. Explain heat transfer. Now they want you to explain heat transfer that take place at each state of the measurement. Okay, so the answer should be like this. Okay, now you look at here the answer. I have the answer here. You follow step by step. When the thermometer is placed under the tongue, usually put under the tongue now. What happens is heat transfer from the patient into the thermometer. You must write this point, you know. You say the moment you put the thermometer under the tongue, right? Then first mark given is here, heat transfer from the patient into the thermometer. You must say this, you know, because at that moment, this person's body temperature, because he's having fever, right? His temperature is higher. So heat will transfer from the body into the thermometer. The thermometer is in the room temperature is lower than the body temperature. So heat transfer from the patient into the thermometer. Then what happens next is the mercury expand. Okay, because mercury absorbs the heat, so it will expand. Expand to show the temperature increases. Okay, the mercury expand to show the temperature increases. Temperature go up, right? But it will not continue to go up. Okay, later on, after thermal equilibrium is reached, you have to write this, you know, use this concept. Thermal equilibrium is reached. Then what happens? The temperature of the patient and the thermometer become the same temperature. Okay. When thermal equilibrium is reached already, right? So the temperature of the patient and the thermometer become the same, right? Become same temperature. And the temperature is taken then. That's it. Okay. And that time, when thermal equilibrium, that's why you have to wait 1 minute, 2 minutes. Wait until the thermal equilibrium is reached, then only you can pick out the thermometer and read. Understand? Okay, so write down the answer now. Okay. Got it? Yeah. Okay, next. Don't worry if you cannot copy now. Later on, you can go and see the video. See the video in the YouTube, then only you copy. Okay. All right, next I want to discuss is the essay question. Okay. Essay. I see the whole question. What the question asks about. Okay. The table shows the characteristics of 6 types of thermometer. There are 6 types. Read P, Q, R, S, T, U. 6, you are going to choose 1. Okay. And they are given a few aspects that given. They ask you to consider the liquid use. Liquid use are between mercury and alcohol. They ask you to choose 1. And why you need to choose this one? Then you must give this one. Second one is glass wall bulb. I told you just now, right? The bulb. The bulb must be thin. Thin means heat easy to go inside, so more sensitive, right? Diameter of the capillary tube, the capillary tube must be narrow. Narrow means the diameter must be smaller, And this one is a little bit of confusion here now. Glass ball stem and the cross section. Okay, stem, glass ball stem. Stem referring to this one, okay, glass here. The body part. The body part here is stem, not is stem. Stem is the body. Bulb is here. Okay, here the glass must be thin. But here the stem, the body must be thick. Thick, you know. Why thick there? Because the thermometer is stronger, not easy to break. Understand? When the body, the stem here is strong, thick, right? Okay. And the cross section mean what shape? Curve shape or plane shape, or square shape, which one you want to choose. Okay. Right? Okay. So there's a little bit of thing you need to read here, you know. Additional information given in the STM. You see, freezing point of mercury is -39. The mercury will frozen when the temperature -39. Okay. Whereas the boiling point mercury is 360. Okay, it's high now. The other one is the freezing point of alcohol. I see alcohol, the freezing point is lower, you know, it's -112. You must have this low temperature, -112, then the mercury only will frozen. Okay, will freeze lah. Whereas the boiling point alcohol 78 a bit low lah. Okay, now remember, the range of temperature we supposed to measure is between, in the question mentioned, right, -40 to -8. Okay, between this temperature, -40 to so you must choose the freezing point lower than -40. And then the boiling point must be higher than -8. I think it's not a problem. Okay, to answer this question, so you answer inside a table like this. Okay, come, let's see the answer. Yeah, like this. Yeah, 2 columns. Left side you put your suggestion is what. Right side you give the reason why like that. Okay, and now all the answer here. Tan Choming coming again. Tan Choming, what happened to you? You went out just now. Okay, now you see we give suggestion one by one. You know. First, you follow the table. Just now here you see. First one is liquid use, right? Liquid use. Second is this. Third is this. Fourth is this. So we have to follow one. Okay, the first answer you give. Liquid use is alcohol. Okay, we choose alcohol. We don't choose mercury. The reason you already know, right? The freezing point is -112. Okay, which is lower than the -40 degree, the lowest temperature in the place. Okay, the lowest temperature in the place was -40. That's why we choose alcohol. The reason is alcohol freezing point -112, which is lower than this. Okay, mercury cannot, because mercury the freezing point is -39. 39 is higher than this, higher than -40. They say cannot be used. Before you can reach -40, the mercury already frozen, so cannot be used. Okay, that's why we choose alcohol. Okay, the reason is freezing point -112 lower than this lowest temperature. Okay, The second answer suggestion is thin glass wall bulb must be thin. Okay, the reason is heat transfer faster into the thermometer. So the thermometer is more sensitive. Okay, this is T, thermometer more sensitive. Okay, heat transfer faster because the glass is very thin, right? Thin, so the heat can go in faster lah. Okay, heat transfer into the thermometer, so the thermometer is more sensitive, right? Okay, number 3. Small diameter of capillary tube. The capillary tube inside the diameter must be small, narrow, right? The reason is alcohol expand faster. Thus, the thermometer is more sensitive. Okay, so you can expand faster. The mercury go up fast, and then very sensitive, can respond very fast, right? And 4th, thick glass ball stem. The stem is a body, must be thick, thick. The reason is Thermometer not easy to break, not easy to break lah. The thermometer not easy to break because the body is very strong, very thick, right? And last, curve cross section. We choose a curve shape one. The reason is easy to hold. That's the reason many students don't know how to answer. That's why you see our pen. Pen also curve shape one. Easy to hold. Like this, easy to hold. Correct not? Thermometer also curve shape, but easy to hold. Understand? So easy to hold. And finally, you need to repeat again. You choose the best is thermometer T. Right? One sentence. Thermometer T is chosen because you repeat again. Its liquid use is alcohol, thin glass wall bowl, small diameter of capillary tube, thick glass ball stem, and curved cross section. That's it. Finish. All this you get 10 marks. Okay, 10 marks. You write all this, They say question. Okay. If you can give all this answer like this, you will get the full marks, 10 marks. Okay. Understand now? Juling, understand or not? Juling, where are you? Juling, chị quay về đây chị đúng không được. Okay, finish. Okay, you can copy this later. Okay, calculation last part. Okay, you see yourself. Last part calculation. The question is like this. D. A thermometer which is not calibrated, mercury length, XCM, when the temperature 0 Tanchoming coming in. Okay. When 20 cm, when the temperature is 100, mercury column is 5. Put in the X, determine the temperature, find the temperature at that moment in Kelvin, and state the thermometric property used. Okay, so the answer are here. First, use this formula. L theta is 5, L0 is 8, L100 is 20, temperature 100, the mercury length 20, 0 degree XCM times 100. We calculate, we get negative 25. Change to Kelvin by adding 273. Change to Kelvin, so you get this answer. Okay. And the last one is to bring the thermometric property used here is the volume of mercury varies with the, sorry, not volume of mercury. It's supposed to be what? What thermometric property here? King Sing Yu. It's not mercury, it's supposed to be what here? The volume of what vary with the change in temperature. Justin, Justin?
Alcohol.
Yes, supposed to be alcohol. Alcohol here is not mercury. Because we choose alcohol already. Alcohol. I'm writing very thorough. Alcohol, okay? The volume of alcohol vary with the change in the temperature. Okay, Okay. So I think we have finished this lesson already. Okay. Yeah. I know some of you still want to copy or let them copy first. So far, any question to ask and what you all? So anything to ask? Anything to ask? Juling? Any question to ask? Juling? Anyone want to ask any question or not? Juling said, no, sir. Too shy to ask, okay? Everyone do want to show your face and all, okay? I think one day I need to ask everyone to show your face and all. Only I know whether the true person is there or not. So I want to make it like this. Maybe I ask you to show your face on your video, okay? Amanda, any question to ask or not? Amanda?
No, sir.
Huh?
No, sir.
No, sir. You see, or no, sir. Yes, sir. No, sir. Like that. Kian Leong, anything to ask? Kian Leong?
No.
No, or no question. Okay. Justin, I want to ask you. Justin, you got any question to ask or not?
No.
No. Yong Jian Wei, any question or not?
No.
No. Yong Jian Wei also no. And let me see others' names. Lim Ching Wen, any question? Lim Ching Wen?
No.
No question. Ong Chao Xian, any question? Ong Chao Xian. He has a lot of questions to ask one. Ong Chao Xian.
No, sir.
Oh, no question. Ho Wan Yin, any question? Ho Wan Yin.
Sir.
No, sir. Yes, sir. No, sir. Like that only. Or Liao. Liao Ping Hao, anything to ask?
Oh,
No question. Esther One got question or not?
No,
One?
sir.
No, sir. Or no, sir. Cecily, any question? No sound. This one no sound. Cecily, no sound. I think I called a friend. Cheris, any question? Cheris?
No, sir.
No, sir. Your friend still around or not? This are Cecily around or not, Cheris?
Yes.
But she doesn't want to talk now. Okay. Kitchen, are you there? Lim Kitchen, Leong Kitchen.
Yes, sir.
Got anything to ask or not?
No.
No, okay. Okay, if no, we still got a little bit time, so we carry on now. We move on. Before 10 o'clock, I will stop. I don't want to drag so long. So this paper finished already now. Okay? All right, now, of course, we need to continue with lesson 2. Lesson 2 is more difficult already. Got this paper or not? Lesson 2? Hong Chao Xian, do you get this paper? Hong Chao Xian,
Yes,
you have this,
yes,
you have
sir.
this paper.
Yes, sir.
Liao, do you have this paper? Liao Ping Hao?
yes, sir.
Then what about this? How? I don't see his name, but I know how is there. How? Are you there? How? How disappeared already? Okay, never mind. This paper Okay, this is the second lesson which is very important one, is understanding specific heat capacity. A new term for you all. What is specific heat capacity? The symbol is C, you have to remember, In Form 4 physics, right, you learn specific heat capacity. Then later on, you learn specific latent heat. There are two types, two new things for you. What is specific heat capacity? Okay, let's see something important. When you need to highlight, you can highlight it. Okay, you start from here now. First, we go and understand that you write a C here. The symbol for specific heat capacity is C. Okay, C. a capital C. Okay. When you see the letter C means stand for specific heat capacity. It's a new terms, you know. Specific heat capacity. Huh? Okay, the meaning of specific capacity you read from here. Highlight. Then come in. Yeah. The specific heat capacity of material is defined as, okay, highlight, amount of heat required to raise the temperature of 1 kilogram of substance to a temperature of 1 degree. Please put it here. The meaning of specific heat capacity, start from here, no. Is the amount of heat required to do what? Required to raise the temperature of 1 kilogram of substance by 1 degree Celsius. Understand the meaning? Meaning that how much heat energy is needed to increase 1 kilogram of the substance by 1 degree Celsius. You remember, no? Must be 1 kilo, 1 degree, because it's specific. Specific to 1 kilo, 1 degree. So how much energy need to make this thing 1 kilogram of thing temperature go up by 1 degree? That amount of heat is called specific heat capacity. Why specific? Because specific to 1 kilo, 1 degree. Okay, that's why you call it specific heat capacity, you know. Okay, I just want you to listen a little bit more, like you listen here now. The reason you learn all these things is important, you know, because the material, different material, they give different values of specific heat capacity one, you know. Okay, I want to ask you, a piece of iron, very easy to heat up, right? Not iron, when you heat up iron, very easy one. You know why? Because iron need less energy to heat up 1 kilogram by 1 degree. Iron very easy. Meaning that iron need less heat energy to heat up 1 kilogram of iron by 1 degree. That's why usually the specific heat capacity of iron is small. Why small? Because it needs less energy. Less energy needed to heat 1 kilogram of iron to 1 degree Celsius. Okay, compared to water, I think water 1 kilogram of water. 1 kilogram of water is roughly like 1 jar, big jar, 1 liter. 1 kilogram of water. You want to heat up 1 kilogram of water by 1 degree. Do you think easy or difficult compared to iron? Difficult, isn't it? That's why water more difficult to heat up. That's why we say water has larger specific heat capacity. Because why larger? Because water need more heat energy to heat up 1 kilogram of water by 1 degree. So you can see the difference or not? There are a lot of things later on you're going to study one, you know, what is some small specific capacity, what is some big specific capacity, right? Okay, come. The SI unit for specific capacity is joule per kilogram per degree. This unit is very long, remember, no? Joule per 1 kilo per 1 degree. That's why we put that joule per kilogram per degree Celsius. Is always remember it. You remember the concept. How much energy need to increase the temperature of 1 kilogram of this substance by 1 degree? So the unit is joule per kilogram per degree Celsius. Per 1 kilo, 1 degree. Okay, remember, you know, this unit, okay. The next, this is a common property you see here. A substance with a large specific capacity. Example I told you just now was water. Okay? Large specific capacities, for example, water able to store a lot of heat, will experience smaller temperature rise when absorbing heat. Okay, but water difficult to heat up. You know why? You know, because when you keep supplying heat to the water, the temperature will go up very slow. You know why? Because our water keep the heat and keep it inside. You know, the water will absorb the heat energy, keep inside, then the temperature will only go up a little bit. I mean, water has better, more ability to store heat energy. Store the heat energy without increase the temperature. That's why we say, you look at here, you say substance with large specific capacity able to store a lot of heat will experience smaller change in the temperature. Water lah. Okay. Compared to iron, small specific capacity. Small specific capacity means the iron cannot store the heat one. Absorb a little heat already, the temperature go up. Absorb a little bit of heat, temperature go up, meaning the iron cannot store the heat. Okay, cannot store mean you make the temperature go up lah. Okay, yeah. Compared to water, water very good in storing the water because you supply heat to the water, water absorb, then store the heat without make the temperature go up fast and all. That is the reason. So you remember like this now. Material with large specific capacity, the specific peak, right, is difficult to heat up. Whereas material with small specific capacity, small, easy to heat up. Okay, like iron, easy to heat up. Okay. Now, lesson 2, you learn this formula. Q equal to mc theta. You have to remember this formula in your whole life. Q equal to mc theta. Okay, what is Q? Q is heat energy. Okay, heat energy supplied to the water, supplied to the iron. So heat energy. Okay, Q. M is a mass lah, mass of the water lah, mass of the iron lah, right? Mass in kilogram. C is a specific heat capacity value lah. Specific heat. Every substance in the world will have their own specific heat capacity one. Iron got small one, water got bigger one, plastic also big, wood also big, correct not? Aluminium small. Every single substances in the world will have their own values of specific heat capacity. Understand? Okay, heat. And theta is a change in the temperature. Okay, so remember you want to find the heat energy, use mc theta, mass times specific capacity times change in temperature. Okay, right. Please answer this question. Try to answer this question. Everybody, try. A metal of mass 2 kg. Calculate the amount of heat that must be transferred to the metal to raise the temperature from 30 to 70. Okay. And specific capacity of the metal is 500 joule per kilogram per G. Very small. Small means very fast, can heat up now. Then calculate, everyone. Esther 1, you got the answer already? How can she say yes? How very quiet when you talk. Okay, I think you got the answer already, right? Let's see. Recheck your answer now. Use it simple, very simple step only. MC theta, M is 2, C 500, theta 40. Change in temperature 30 to 70, so it's 40 degrees lah. So you get 40,000 joule. Okay, that's the answer. Correct not? I think okay now. Everyone can get the answer lah. Okay. Okay. Now second question. Can you try this question? Try to answer. 8.4 10 power 5 joule of heat energy raises the temperature of 4 kg of water from 40 to 90. What is the specific capacity of water? Now they ask you to give you the energy. They ask you to find the C, specific capacity of a water, right? Find first, okay, everyone? Enough? Okay, check your answer. Okay, the answer is here. Here we go to MC theta. Q heat energy given already. This value. Mass is 4. C you don't know. You have to find change in temperature theta 50. Okay. So the C value is 4,200 joule per kilogram per degree Celsius. Okay. This value. I encourage everyone go and memorize it. This is a specific heat capacity for water. Water, you have to remember, 4,200 joule per kilogram per degree Celsius. This one is special for water one. So water, you have to remember, put it here. The specific capacity C for water is 4,200 joule per kilogram per degree Celsius. It means what now? It means what here? Okay, listen, I say once only. Later when I ask you, you let me know. Okay, the specific capacity C for water is 4,200 joule per kilogram per degree Celsius. It means that to heat up 1 kilogram of water for 1 degree Celsius, to heat up 1 kilogram of water by 1 degree Celsius, you need 4,200 joule of heat energy. That is the meaning. That bring the meaning, For water, you want to heat up 1 kilogram of water by 1 degree, you need this amount of heat, 4,200 joule of energy, heat energy. Understand? Lim Sing Yin, understand? Lim Sing Yin, are you there?
Yes, sir.
Do you understand? Lim Sing Yin, understand or not?
Yes.
Yes. Okay. Carmen, are you there?
Yes, sir.
Carmen, can you answer this question? I give you a question. Can you answer? Can you listen to me or not?
Yes, sir.
Okay, Carmen, I ask you one question now. Specific heat capacity for aluminium. Specific heat capacity for aluminium is 900 joule per kilogram per degree Celsius. I repeat the question. Specific heat capacity for aluminium is 900 joule per kilogram per degree Celsius. What is the meaning? Carmen, what is the meaning of that statement?
900
900 joule
of heat
energy
needed
for what? Needed to 900 joule of energy needed for what? Justin, can you help? Justin, are you there?
Yes.
Can you help to answer?
It means that we need to heat up 1 kg of aluminum by 1 degree Celsius.
Yes, correct.
We need 900 joules of heat energy.
Yes, correct. That is the meaning now. If 900 means 900 joule of energy needed to heat up 1 kilogram of aluminum by 1 degree Celsius. Understand? Or you may understand? พอซิลไหมกันวันยู understand
Yes.
กันวันยู do you understand กันวันยูหนูเศร้าอะไรดิยังไม่ละครับ we move on นะโอเคalright now we got another thing you need to learn here okay now this mixture now this one is more difficult okay class you all listen properly okay mixture is what whenever two materials are at different temperature and in thermal contact the hotter material will lose energy by transfer to the colder one until both come to the same temperature and they are now in thermal equilibrium. This one you know already. Okay, mixture means you mix up two things. One hot one, one cold one, you mix them up. When you mix them up, you see what happens, right? Okay, now, after I explain this example 3 to you, you understand already. Can you look at this example 3, everyone? Follow me, please. This question, follow. Okay, this question sounds like this, you say 0.2 kilogram of water at 100 degree here. 0.2 kilogram of water, 100 degree one, hot one. Mixed with 0.25 kilogram of water at 10 degree here. 0.25 kilogram another water, but this temperature is only 10 degree. Then we mix them up, This 0.2 kilo, 100 degree hot one. Mixed with 0.25 kilogram of water, temperature 10 degree, you mix them. When you mix them up, you pour this water inside here, you mix them, this can become mixture. Then what is the final temperature? You need to calculate, 10 degree, 100 degree, 0.2 kilogram hot water. Mixed with 0.25 kilogram water, cool one, 10 degree. Let them heat transfer until thermal equilibrium is reached. Then what is the final temperature, theta? How to find this theta? When you mix a hot, cold, you mix them, right? Finally, what is the final temperature? Final temperature means when both become the same already, it becomes same temperature. So how to solve this problem? Okay, see carefully, we use this concept, We say Q is heat, heat released by the hot water equal to heat absorbed by cold water. You remember, the concept is like this, hot, cold, you mix them, right? So the hot one will release the heat, cold one will absorb the heat. So we assume heat released by the hot water equal to heat absorbed by the cold water, same one. We assume no heat loss to the surrounding. We assume all the heat energy, right, from the hot water absorbed by the cold water. This assumption always asked in SPM question. They ask you, what is your assumption? So our assumption is what? We assume no heat loss. All the heat energy from the hot water absorbed by the cold water. No heat loss to the surrounding. But in reality, this thing won't happen once. Just some of the heat will run away one. Understand or not? Yeah? Okay, now you see the solution. Very simple. Q, heat released by hot water, formula M1C1 theta 1. Same, use the same formula. Heat absorbed by cold water, also M2C2Q2, theta 2, sorry. You use the same formula, MC theta, but you put 1 here, 2 here. Now you see here, C1, C2 I cancel. Why can cancel? Why the C1, C2 can be cancelled? Liao Ping Hao, why can cancel C1, C2? Liao Ping Hao, why can cancel one?
I don't know.
So Ong Chao Xian, why I cancel C1, C2? Ong Chao Xian?
The specific heat capacity is the same.
Yes, very good. Because both are water, water 4,200, same one, that's why you can cancel. C1 for hot water, C2 for cold water, same one. The C value are specific capacity value, same one, so you cancel it off. So can cancel, understand? So remember now. Okay, now get more detail. Okay, now M1 is this one 0.2, so you substitute here. C cancel it. Okay, theta change in temperature is 100 minus theta. Okay, let me explain to you. This one is 100 degree. This one is 10 degree. The final temperature is roughly in between 10 to 101, sure one. Okay, must be in between 10 to 100. We don't know what temperature, but must be within 10 to 100. There's a change in temperature for the hot one. You take high temperature 100 minus theta. You take the higher temperature minus the final temperature. Okay, 100 minus theta. Whereas for cold water means 0.25. Change in temperature is theta minus 10 because final temperature are still higher than 10, correct? Not. You must have this concept now. This final temperature must lower than 100. Then must be higher than 10 in between, correct? Not. Is a change in temperature, you take big value minus small value. Then this one bigger than this, so theta minus 10. Here is 100 minus theta. Understand? Here, don't mistake, You always take the high temperature minus the final temperature, the higher one. Whereas the lowest temperature, you take the final temperature minus 10. Because theta lower than 100 and theta higher than 10, correct not? So here 100 minus theta, here theta minus 10. Okay, open bracket. Multiply, open bracket, you get this. Here multiply, open bracket, so you get this. Okay, after this one, I think you know now, put the theta together, this one bring over, finally you get 50 degrees Celsius. The theta value is 50. So meaning that the final temperature is 50 degrees Celsius. When you make this 10 degree, 100 degree, mix together, finally it becomes 50 degree. Copy down the example, please. It's very important. Copy down. Okay. Okay, 10 o'clock already. So I think I want to stop here. Okay, before this, can you answer this question? Try to answer this question at home first, okay? The objective question, okay? Here you answer the objective question, okay? Try to do it at home. Objective question, okay? Okay, I tell you you can do from question 1 to page 1, you 1 to 9, okay? Question 1 to question 9. Okay? You answer the question on page 11. Question 1 to question 9 are the objective question, all right? So okay. Wednesday, I want to see you again, Wednesday. Okay, every day 1.5 hours, 1.5 hours. So today, 2 days become 3 hours. I want you to come 2 times or 1 week, so that you keep you busy, so that you won't forget my physics. Want to make you always remember physics. Okay, the 1 week 1 time only, then you forgot already. You don't came start time already. So that's why I want you to see you on Monday and also Wednesday. Okay, right? So for today, I'm going to stop here. So please answer question 1 to question 9. Try to answer. Okay? So thank you very much. Okay. Bye-bye. See you again. Bye-bye.
Thank you, teacher.
Thank you,
Okay,
teacher.
bye-bye. Bye-bye.
Thank you, teacher.
Thank you,
Yes,
sir.
bye-bye.
Thank you,
Thank you,
sir.
sir.
Thank you,
Thank you,
sir.
sir.
Thank you,
Okay,
sir.
bye-bye.
Sir.
Okay, bye-bye, bye-bye.
Bye bye.
Thank
Okay,
you, sir.
bye-bye.
Thanks, sir.
Okay, bye.
Thank you, sir.
Bye. Bye. Ya, bye ya.